Hello, we've had a question in the Calculus and Vectors course, Unit 2, Lesson 11, number 9. Find the scalar equation of the plane that's perpendicular to that plane. So let's start with that. So, just going to draw myself a picture. So here's the plane. So I'm going to call that, there's my arc plane right there. All right. And it's perpendicular to that plane. So that means that the normal to that plane, all right, is going to be a direction vector on my new plane. So let's start with that. So from this plane, I've got two direction vectors. So the first direction vector is 5, -2, -2. My second direction vector is -1, 0, and 1. So I can find the normal to the plane by taking a cross product. So we're going to do d1 cross d2. And that will give me, do the rough work here, -2, -2, -1, 0, 1, -1, 0, 1. So the first one will be -2, 2, take away 5 is -3, 0, take away +2, so it'll be -2. So there is my normal. All right, so there is the normal equals the normal for my new plane. All right, so we've got that. And it intersects along that line there. All right, so that means that that line that they gave us right here, so it intersects it along the line. So that line, the way I read that, is that the line is going through the point. So maybe erase that. Hold on. So that line, maybe it's over here. So our new plane is going to face that direction. And it intersects it along that line. So it's that point that's interesting. We want that point right there in our new plane. So now I have a normal for my new plane. So the normal again was -2, -3, -2. And I've got a point on my plane, 9, -1, -5. So if I have a normal and a point, I can come up with the scalar equation because it'll be n multiplied by Q naught P equals 0. So -2, -3, -2. Dot it with x minus 9, y plus 1, z plus 5 equals 0. So we'd end up with -2x plus 18, -3y minus 3, -2z minus 10 equals 0, -2x minus 3y minus 2z. I got 18, I got 8, I got 5. And they probably report it with all positives. So I'll switch my signs around here. So I would say, if I've done my arithmetic properly throughout, that is the equation of a plane that is perpendicular to the original one, and it intersects it along that line right there. So I use that reference point to find that point. So it incorporates the 9, -1, -5. Yeah, that should be the answer that we're looking for. If there's any questions or you need any further assistance, let me know, and I'll see what I can do to help out.